This is me 5 years before actually taking Kubernetes seriously. Just as a note. Okay. So a little bit about me. So I'm a principal site reliability engineer at UiPath. I do a lot of reliability work, maintaining infrastructure, deleting infrastructure. That's actually my passion. I treat basically everything as cattle, with the exception of my wife. But yeah, that's pretty much it. My mantra is create, deploy, delete. Everything has to be immutable. Everything has to be ephemeral. That's my principle. That's what I want to do. I don't want to manage things. I don't want to treat my servers as pets. I want to treat them as cattle. If something goes wrong, just get rid of them, redeploy, we're golden, back again. That's pretty much what, in light lines, what I do at UiPath. Besides that, I'm Microsoft Azure MVP. That doesn't mean I work for Microsoft besides UiPath. It's an honorary title that I was granted to me by Microsoft for activities that I do in the community. Organizing conferences, meetups, speaking here on this stage. Everything that I do for the community, I give my knowledge to the community, and Microsoft rewarded me with an MVP title in the Azure category, which grants me, besides an honorary title, it grants me access to the product groups. So every time something goes wrong in Azure, and I have a problem with it, I don't go through support. I go directly to the guys that wrote that actual service, and I bitch about it, basically. And I give feedback. Let's make it more nicely. Okay, so the title of this session is a little pompous. It's not written with ChatGPT, by the way. So just so you know, it was written by me. I know it's something that happens lately, writing sessions with ChatGPT. And the session basically is talking about services that are in Azure, add-ons that are in Azure that can make our Kubernetes cluster, our AKS clusters, much more easier to manage and have less and less problems and less of a headache. But before that, the cloud reality. So we're here, basically, and we have this problem right here. Now, other images like this say, here are the problems, but basically, when we talk about managed Kubernetes, out of the box, every Kubernetes system, if we're talking about EKS, GKE, AKS, they are called managed, but they're actually semi-managed. Only the master plane is managed by Microsoft, but you have access to the data nodes. So if something goes wrong to those data nodes because you did something, or something happened, or you did a deploy, and those data nodes crashed, or you deleted the resource group that contains them, that's on you. That's not on Microsoft. So when they say managed, only the control plane is managed. You have access to all the data. So you don't have access to the etcd database. You only have access to what you deploy and the nodes that you deploy. Now, that's the main idea. Out of the box, when you deploy Kubernetes, it's not just, okay, we're going to deploy our app and everything is nice and dandy and roses and everything. We have to do a lot of work. And that work starts with deploying our application, managing our application, governing our application, securing our application, securing our cluster. Or when something bad happens, we go into a corner and cry because Kubernetes had a problem. We did a Terraform apply without looking exactly at the plan, and our cluster gets deleted. True story. Did that. And things like that. We have a lot of work to do when it comes to managing Kubernetes. It's not like something simple, out of the box, deploy it, it works, our application works, and we don't do anything about it, and we just manage our application, and we just deploy our application. And the reality is, if you are picking our poison, wherever we go, wherever we talk, wherever we deploy, all of them are similar in nature, because it's Kubernetes under the box. If we're talking about GKE, EKS, or AKS, it's the same thing. It's Kubernetes underneath. They have some bells and whistles, each and every one of them, that get attached. You get some management outside your area of control, so that's good. You don't have to manage data master nodes and data nodes and things like that. But in the end, you still have to do a lot of management. It's not that simple. There are solutions out there. You have AWS Fargate, which makes it much more simpler, but that's pretty much it. Google makes the best Kubernetes experience from an out-of-box developer experience, but still some work out of there. Now, solutions exist. On one side, we have the problem, we need to have full control of our clusters. On the other side, we have serverless, which was the 2020, 2021, and 2022 buzzword. Everything has to go serverless, and Amazon was the first to migrate all their apps from serverless because it was too damn expensive. And they found out, okay, if we don't do serverless, we have a 90% decrease in costs. So we have the possibility of doing deployments in serverless containers. We have something called container instances, container apps, and we have but most of the management outside of our area control. But when we look at the cost, when we want to scale a lot, those costs go a lot higher. Now, the key point of the session, I just told you, we're going to look at what Azure gives us in terms of add-ons, services, plugins that they manage. It's not our problem. This is what we're going to talk about. If we go on GitHub and we install something, then that's our problem. We install Nginx, it's our problem to upgrade Nginx. We install Istio, that's our problem as well. Every single time something happens, we have to check, okay, is it a breaking change? Maybe, maybe not. Until you do an upgrade in dev and staging and you figure out what the problem is and you actually find the problem in production, that's on you. Now, these are the tools that I'm going to talk about that are managed by Microsoft. Now, all of them are open source. There's nothing special about them. The only special part is that you don't manage them, Microsoft manages them. Okay, let's skip. So, the first one that I'm going to talk about, this is an Azure product, the workload identity. This is actually version 2 of something that was called AAD pod identity, which was a system that granted you tokenless managed identity support for accessing services and credentials. So imagine we don't need any keys, any secrets saved in Kubernetes. We don't need anything. We just install this controller, and that controller goes to a managed identity, and that managed identity goes to that resource, and everything is hunky-dory. The problem with AAD pod identity was that it didn't scale. You wanted to go 100 nodes, 200 nodes, 300 nodes, not gonna happen. You had an injected sidecar in your pod. That sidecar basically was a connection to the managed identity, and when you wanted to scale that pod to, let's say, 20 instances, you would have 5 more to go until it started crashing. And it started crashing at about 15 pod instances. And that was something bad, okay? We want a keyless solution, but this one doesn't scale. Now, workload identity is something simple. It's the same principle. We have a controller installed in our Kubernetes cluster, but we are using more, they're using more normal ways of connecting to services. So you have an OIDC issuer on the Kubernetes cluster, you set up a federated credential on a managed identity, and then using the controller, you link them between them, you create a service account, and that's it. And from a code perspective, we just need to import the Azure library, SDK library for this. Default account, it's in Python or whatever, and it just works. So I wouldn't go far to say 2-line changes, but usually it's 2-line changes in our code, and we are adopted workload identity. And from an installation standpoint, it's quite simple. So if you want to install workload identity in your cluster, basically you have something like this. AKS update. This is a blank screen. Yes. I'll walk you along. AKS update, give me the resource group name, give me the cluster name, then these 2 flags, enable OIDC issuer, enable workload identity. From that standpoint, we are enrolled in OIDC, we get an OIDC issuer. From there, we have the system installed in our Kubernetes cluster, and it's managed by Microsoft. And if I go to, let's say, all namespaces, and I check Helm, I'm not going to zoom again because apparently zoom blanks the screen out. I'm going to try a little bit. Let's see. Okay, we have this. This is installed by Microsoft. That's it. From here, we just need to create a service account, give the ID to a managed identity, and we're golden. From instantiating it into other pods, we just need to reference something in our Helm chart says use Azure Identity, and that's it. It's an annotation. We add that on annotation, and it works. And you could say automatically it works. And from that point, if I go here into the, which one was it? Let me remember. Am I federated? You cannot see that much, but let me zoom. This is the YAML that you have to apply in your cluster. You can apply it however you want. Helm, kubectl, apply however you want it. This is everything that you need to start workload identity. And in Azure, if you go to Azure, this is a managed identity. We have it here. We go to federated credentials, and we have these AKS federated identities with an issuer. That's it. No keys involved, no secrets involved, no secrets to rotate, nothing to do about it. If you delete the identity, that's on you, but that's it. And this identity I can assign RBAC to any Azure resource that I need. I can install all the plugins and leverage this workload identity plugin, and from there, that's it, not my problem. And when I want to do anything to pull connections things, connect to SQL databases, pull secrets from Key Vault, app configurations, whatever, this is the way to go. And then we don't need any more secrets or special secrets in our Kubernetes cluster to fuss about. That's pretty much it. This is workload identity. We can have multiple identities attached to a cluster. We can have pods that get instantiated with managed identity, so we need the managed identity to be instantiated as a sidecar on the pod, or you can just use it as is, and that's it. The next one on the list is vertical pod autoscaler, which is also managed by Microsoft. It's something that they created to work hand in hand a bit with HPA, with horizontal pod autoscaler. Horizontal pod autoscaler, as you may know, when my pod has too much load, it scales this way, adds more replicas. Now we have applications that we might not have that memory leak in control yet, or we have spikes in our application that jumps up the memory too much or jumps up the CPU requests a lot, and we need a way to scale that up gracefully without having issues and doing resource management, checking resources and things like that. So vertical pod autoscaler, similar command, similar idea. Basically install it in the cluster, you annotate that we need to use vertical pod autoscaler, and when the pod actually gets to a point where I need more memory now, a new pod gets deployed. A new pod starts, the other one gracefully gets killed, and then you have more resources on it. Now, there are some limitations on them. Windows nodes don't work, but nobody cares anyway. And you can have a maximum of 1,000 configured pods. So you have a big limitation, so you have more than 1,000 pods with VPA installed, that's a problem. Now, for VPA, that's actually simple. So let's see here if the command works. Yes, it doesn't work, awesome. It's not digitally signed. I love my work laptop. Okay, let's see, hamster. Okay, kubectl, apply. So, I have VPA installed. I have a problem with it. It doesn't work, obviously, as usual. If it doesn't work, I'm gonna ignore it. Oh, I screwed up the spec. Never mind. You can trust me about it. A pod pops up, then it's a simple test, a demo. The pod pops up, it starts ranking up memory, then you're gonna see another pod popping up, and it adds more memory to it or CPU to it. That's pretty much it. Now, the next one we're going to talk about, this is more awesome. So if everything was meh so far, this one is the most awesome one of them all, node auto provisioning. Now, if you heard about Carpenter or AWS Carpenter, there is a solution for that. Node auto provision basically gives you a managed solution for a Carpenter-based deployments. So you create an AKS cluster, you tell it to be Carpenter deployed. It comes with some limitation. It has to be a Cilium deployed AKS cluster, so Azure CNI Cilium for it to actually work. But basically, it's a system that decouples the node types from Azure. So every time you need a specific SKU, a specific virtual machine SKU, a D series, a B series, a whatever series, you have to go into the Azure portal, you have to create a node type, you have to set up cluster autoscaler, you have to set up labels, taints, and things like that, so those pods can go actually on those nodes. Now, node auto provisioning with Carpenter solves that problem. So the idea is we have pending pods. So when we create a deployment, maybe our deployment scales up with whatever solution we have, and we have unscheduled pods. Those pods will be seen by Carpenter and will provide you with a just-in-time capacity. So we need something. I need a D-series VM. How many? You figure it out. I'm just going to set a limit. And from there, we can go far and beyond and say, OK, if this pod with a specific GPU type scales up for whatever reason, maybe it's on a cron, maybe it's triggered, scheduled whenever, then Carpenter can see, okay, it's an unscheduled pod, goes to Azure, give me that machine, add it into the node pools, and then schedule that pod. And when that pod is finished, guess what? It gets terminated, zero capacity, Carpenter goes, delete that node. So you have cost management as well. Instant, not quite instant, it's the cloud anyway. It's almost instant capacity addition, but you get cost control as well. I don't need it anymore, I'm going to delete it. And this one, I hope this demo works. This is pretty simple. So I kept the pod there, and I'm going to do it like this. Scale. OK. So as you see right now, I hope you're seeing right now, I have a lot of pods that are getting scaled right now. They're pending. I don't have capacity for them. So if I go and say, OK, what's happening here? Let's say, does it work? Yes. It says insufficient nodes. I don't have capacity. So in normal scenarios, cluster autoscaler would see that and add more capacity to the nodes. But in this case, cluster autoscaler is disabled, and we have Carpenter enabled, which goes after this and says, OK, I need to schedule these pods on a node. And beneath the water, Carpenter is now polling Azure, telling, give me a machine so that these pods can get scheduled. So as you see them right now, I have been waiting for them. But at that point, I have AKS node pools, and at one point, a new node will pop up and schedule those pods for me. Now, depending on the SKU types, it can be faster or can be slower. But that's pretty much it. So as you can see, I'm not doing anything. At the moment, I'm waiting. And whatchamacallit, the YAML for this, it's actually quite simple, if I would find it. App config deployment. This is it. OK. I hope you don't see it. Let me fix that for you. I never liked something like this. Teams, color team. There you go. Awesome. Anyway, so I created a Carpenter spec. That Carpenter spec has a general purpose node pool. So it creates a general purpose node pool, and it has some requirements. It looks for AMD 64 architecture. It looks for Linux. It looks for capacity and says, if something is required, create me something in the D SKU. So it goes into Azure and it says, give me something from the D part number, DS series, DV2, DV3, DV4, DV5. And I have a lot of manageability here, and I can say, give me something in this area, or I can go smaller in spec, more granular, and say, I only want this part number because I have reservations deployed for it. So it costs me less if you get me these types of SKUs. And that's pretty much it, what you need to do. And if I go back here, Carpenter is lazy, or Azure is lazy. I hope you believe me, it works. And time is not with me. Anyway, I'll be back to it. So that's pretty much the idea with node auto provisioning. Carpenter is an open source plugin add-on. You can install it right now if you need it. In Azure, it's in preview. The idea in Azure being in preview is you don't do it in production, you don't deploy it in production. There are some limitations, like I said, you don't have an upgrade path or a migration path. With other types of migrations from Azure CNI to overlay to whatever, you have an upgrade path, but with some breaking changes usually. This one says you need a new cluster to deploy with node auto provisioning at this point in time, being in preview. They're gonna add an update. They're gonna add a way of going from Azure CNI Simple to Azure CNI Cilium and then install node auto provisioning, but not now. Just saying this for awareness so you can know about it. Anyway, CSI secret provider. Now, anybody here not managing secrets? No, everybody is managing secrets. When I have secrets inside my cluster, I have to manage them in some way or some form. I have access to them. Now, with the cloud, we have key vault providers, key secret providers. Those systems give me the possibility of adding a secret into a key vault, have granular access control applied to it, and I have the CSI secret provider, which gives me the possibility of injecting secrets from Key Vault directly into the cluster as a Kubernetes secret or as a mountable secret. So we can use it both ways. We can use it as an environment variable, or we can use it as, okay, do a cat on that secret value. And the idea of this is we can have secret rotation made easy. Now, this one is pretty simple. We install it. Carpenter is hating me right now, but this is simple. Now, this is an Azure Key Vault, pretty simple. I have a secret here, which is called KCD secret. I have a version, and if I look at this secret value, I have this Kubernetes very random secure password. This, in general, will need to be instantiated inside the cluster. Now, if I go to secrets right here, and I check, why are my secrets not? Oh, I didn't instantiate them as a Kubernetes secret. If I go into my busy box and I go to amount secret store, and I don't remember the name, there you go, KCD secret. So it's mounted here. It's a text file. We have the possibility of doing it as a secret, and we can mount it as a secret, but we can have those secrets. Now, if I go and change that secret, this KCD secret will be rotated inside the cluster, but our application will not see that new secret. It will require a reboot, but just so you know about it. We have a solution for that even later. This is a simple thing. CSI secret provider, AKS, gives you a way, AZ, AKS update, install CSI secret provider, and it's pretty simple from the Azure docs. Going fast because time is not with me. App configuration, same idea. Imagine feature flags, app configurations, config maps, things like that. We have a solution in Azure as well to inject into our Kubernetes cluster. We have something that gives us a way of keeping key value pairs inside Azure and controlling them from Azure and having them injected inside the cluster. We can manage those directly from Azure, and we can have them injected into the cluster. And it looks something like this. If I go back to Azure, and I check right here, we have this app configuration. It's in Azure, it's a resource, we can manage it however we want it. And in this configuration explorer, I have this key value pair, KCD with a value. And that value appears directly in the Kubernetes cluster under config maps as this, KCD config map. So I just configured the YAML file. I just said, this is the endpoint This is the managed identity that I used, and this is everything that I said right now is tied to workload identity. So I don't need to do anything special. I went, I said, give me that, do that, and automatically it created the config map for me, and I can deploy my applications and referencing that config map. Pretty simple. Now, I would try to do a demo, but as you can see, Carpenter hates me, but let's give it a try. So I'm gonna edit, I'm gonna say Romania demo, I'm gonna do an apply, and let's hope the demo gods are with me. So it takes about, the polling is about 30 seconds, so it takes about 30 seconds to do a poll, but I can force it to work actually faster. So you can still here is still Romania. So if I go right now to the Ask config system, and I do something that you should always do in production and actually delete the pod, because we love doing that. Now when the pod goes back into running state, that config file will be updated. It updates dynamically because it updates, but this is the demo time, we need to do it faster. Now if I go back to default namespace, config maps, and maybe this time it actually works. No. It works, I tell you. I did these demos before. There you go. See, one demo works. Great, okay. So at least I got one demo running. App configuration. Image cleaner. Another thing managed by Microsoft. You can install it in any of your Kubernetes clusters. This is a solution that nobody asked for, but we needed it. It's a solution that actually cleans our images from our Kubernetes clusters. Now, this is not AKS specific. Nothing here is like AKS specific. These are solutions that are managed by Microsoft. No version control, no management. We don't care about that. Image cleaner is a solution that goes inside our cluster and watches the node capacity. Now imagine this, our nodes, every time we do a deploy, our nodes cache images, every time they get cached. And we can have vulnerabilities in those images, maybe we fixed a CVE, we fixed another problem, and they remain on the cluster, nobody cleans them up. You know when they get cleaned up? When you do an upgrade, and nodes actually get deleted, and new ones are being provisioned. Now with Image Cleaner, which is part on Eraser, the open source plugin called Eraser, gets installed into the cluster, and you can set a timer, say every 48 hours, check for stale images. And after 48 hours, it creates a couple of YAMLs and starts deleting those images. And now you know, if you provision your clusters with ephemeral images in Azure, you have a tight capacity, 128 gigabytes, and in those 128 gigabytes, about 1 month of deployments, they're gonna get full. And guess what? What's gonna happen? It's gonna have a node pressure, and everything's gonna fail. So this is an awesome thing, look at it. Now, Azure policy, now I have 1 more minute. Azure policy, based on Gatekeeper, an open policy agent, we can have Azure policies in our cluster. We have Azure policies configured, and we can inject them into our cluster. We have a lot of available definitions around there. We can say basically, we have a policy to not have containers run as root. We can have a policy to not have containers with a specific label and things like that. Same idea, we do a checkbox, AKS install, and that's pretty much it. And we start enforcing the definitions. It's pretty simple. Same idea, works with serverless, so workload identity. Now, I'm gonna do a quick fire round and call out some excellent open source plugins, services, or something like that. One of the things is KEDA. Anybody here uses KEDA? Awesome. In short, KEDA is Kubernetes event-driven automation, autoscaler. Basically, you set KEDA up, you set it with a provider, and based on, let's say, a messaging queue, imagine Kafka, or a service bus. We have messages coming in, those messages need to be consumed, and maybe we get 1,000 messages per second. So we have one pod, KEDA makes sure to scale up to 50, 100 pods, how many you configure. It's easy to use out of the box, look into it, it's awesome. I've been using it for more than a year, and it saved my butt a lot of times, even when about 20 million messages in 1 hour came and it scaled and killed the cluster, but that's a different story. Another one is Kubernetes reboot daemon. So this is from a security standpoint. Cured is a system that nobody asked for, but we need it. So when I said semi-managed clusters, I mean semi-managed. Those nodes that we have, those data nodes that we have, they never get rebooted unless we do an upgrade and they get deleted and new ones get popped up. Every 24 hours, apt install runs on our data nodes, and guess what? Nobody reboots them. So Cured is a solution that looks as a daemon set inside the nodes and looks for a file. They create a file, reboot me. It's not called reboot me, but that's basically it. And it goes and reboots the data nodes gracefully. Does a drain, does a cordon, does a drain, and then reboots those nodes. Awesome tool to have. You need to fiddle with it a bit so you don't have downtime, because some applications are pretty much more complicated. Last one, Reloader. Reloader basically is based on a solution that looks if something changed. I said about app configuration, I said about secrets, but they don't restart all deployments. Reloader restarts all deployments. So we say, look at the secret, look at the config map, and if you see a change, gracefully reboot our deployments so that they can work. And we can have instant key rotation. I change the key in the key vault, automatically get adopted in my pods or my deployments. I'm out of time. Ending thoughts. That's pretty much it on the applications. If you have any questions, I'll be here. If not, thank you so much for being here. Thank you so much for the organizer for this awesome conference, and have a good one.